Now, let us start with the new topic, that is polynomial. First, let us understand its general formula. So, polynomial's general formula, I can say, will be in the form of a0 x raised to n plus a1 x raised to n minus 1 plus a2 x raised to n minus 2 plus dot 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 till a raised to n. That is x reached to the power 0, where a1, a2, dot 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 are real numbers, n is a non-negative integer, a0 can't be equal to 0. This polynomial is called a polynomial of degree n. It is represented by p of x or any of the letters. It can be f of x, r of x, anything. Now, next thing which you should know is degree of the polynomial. The highest power of x in a polynomial p of x is called the degree of the polynomial. Now, let us understand this by an example. So, let me take one example. So, it is given to me 5x raised to 5 plus 4x cube minus 4x plus 3. So, he is asking, is it a polynomial? Yes, it is a polynomial. And the other thing, its highest degree. So, and degree of polynomial is 5. Now, next topic is value of a polynomial. So, here I can say if p of x is a polynomial in x and a is a real number, then the value of the polynomial by putting x equal to a in p of x is called the value of p of x at x equal to a, and it is denoted by p of a. Now let us see one example for that. P of x is given to me as 9x square plus 5, and find the value when x equal to 1. So p of 1 will be, in place of x I will put 1. So 9 into 1 square plus 5. So that is 9 plus 5. So that will be 14. Next, we are going to see types of polynomials. So first type of polynomial is constant polynomial. A polynomial of degree 0 is called a constant polynomial. It is of the form A, where A is any number. Then second comes linear polynomial. A polynomial of degree 1 is called a linear polynomial. It is of the form ax plus b, where a and b are real numbers and a is not equal to b, and a should not be equal to and a is not equal to 0. Then the third pattern comes quadratic polynomial. A polynomial of degree type 2, that is highest degree is 2, is called a quadratic polynomial. And is of the form ax square plus bx plus c, where a, b, and c are real numbers and a should not be equal to 0. Then the fourth one is cubic polynomial. A polynomial of degree 3, that is highest degree should be 3, is called a cubic polynomial. It is of the form ax cube plus bx square plus cx plus d, where a, b, c, and d are real numbers and a should not be equal to 0. Now the fifth type is biquadratic or quartic polynomial. It is not asked in the 10th standard, but then also when we are doing the types, I am taking that into consideration. It is in the higher level, but then also I have taken. A polynomial of degree 4 is called a biquadratic or quartic polynomial. It is of the form ax raised to 4 plus bx cube plus cx square plus dx plus e, where a, b, c, d, and e are real numbers and a is not equal to 0. Now, let us see some of the examples of this. If I am given, the first one is 3x square. So, it will be a quadratic type because the highest degree is 2. So, I have to just see the highest power. Then, if it is given 3x raised to 4 plus 2x cube minus 5x, so this will be quartic or biquadratic. Then the third one is 3x raised to 3 minus 2x square plus 5x minus 5. So this is cubic polynomial. Then it can be 3x plus 2 also. So this will be linear polynomial. Next is zeros of the polynomial. So now let us see that with an example. Okay, suppose I am asked find the zeros of the polynomial. So first, p of x equal to 6x square. Now I am rearranging them in the proper order. So minus 7x minus 3. Now I have to take the factors of this in such a way that it comes correct. So 6 threes are 18, minus 18 such factor whose sum is minus 7. So I can say 6x square minus 9x plus 2x minus 3. So now 3x, if I take common from the first two, I will have 2x minus 3. And from the second two, I am taking 1 common. So 2x minus 3. So now both brackets are common. So 2x minus 3 I am taking common. So in other bracket, I am getting 3x plus 1. So I can say on putting p of x equal to 0, that is 0 of the polynomial means final values of the polynomial should come 0. So 2x minus 3 either will be 0 or 3x plus 1 should be 0. So if 2x minus 3 is 0, so 2x equal to 3, so x equal to 3 by 2. Then if 3x plus 1 equal to 0, so 3x will be equal to minus 1. So x equal to minus 1 by 3. So these two are called zeros of the polynomial. Now with that, one more thing is there. So let us discuss. Next is geometrical meaning of zero of a polynomial. Here in the graph, if you see carefully, the easiest way to remember is where it touches the x-axis, that points you have to select. That will be the zero of the polynomial. So if I see one point is here and one point is here. So I can say there are two zeros of the polynomial given to me. It is exercise 2.1. Here he is saying the graphs of y equal to p of x are given in figure below for some polynomials p of x. So find the number of zeros of p of x in each case. So here I can see clearly in the first figure I don't have uh, any point touching the x-axis. So I can say it as 0. It has 0 zeros. Then in the second one, if you see, it is touching at one point, this point. So here only one zero is there. Then if you see the third figure, 1, 2, and 3 places it is touching. So three zeros. Then in the fourth figure, it is touching at 2 points. So two zeros. Fifth, 1, 2, 3, and 4. So four zeros. And here 1 point, 2 point, 3 point. So 30. I have to only check the points at which it touches x-axis, not the y-axis. So you have to consider only x-axis, not the y. Now next is relation between zeros and coefficient of a polynomial. So for a quadratic polynomial, see this I am talking about quadratic polynomial. If alpha and beta are zeros of a quadratic polynomial, p of x equal to ax square plus bx plus c, where where a is not equal to 0, then alpha plus beta will be equal to minus b upon a, that is minus coefficient of x upon coefficient of x square, and alpha beta will be equal to c upon a, that is constant term upon coefficient of x square. Then if I am given zeros and I am asked to form a equation, so for that also let us understand formation of a quadratic equation. If alpha and beta are zeros of a quadratic polynomial, then p of x will be equal to x square minus sum of zeros into x plus product of zeros. So here if I want to show it, x square minus alpha plus beta x plus alpha beta. Now let us do example based on this. So find the zeros of the quadratic equation or quadratic polynomial 4u square plus 8u and verify the relationship between the zeros and the coefficients. So here p of x equal to 4u square plus 8u. Now, or I should take p of u, not p of x, because u is the variable given. So let me take p of u equal to 4u square plus 8u. Now, to find the zeros, put p of u equal to 0. So that means 4u square plus 8u will be equal to 0. So now taking u common, so 4u plus 8 and u outside equal to 0. So here either u can be 0 or 4u plus 8 is 0. So if 4u is 0, so 4u equal to minus 8, so u equal to minus 8 by 4. So u equal to minus 2. Now two zeros I have got, u equal to minus 2 and u equal to 0. Now let us check the relationship between the zeros and coefficient. So here the zeros are 0 and minus 2. So sum of zeros equal to 0 plus minus 2. That is minus 2, which is equal to minus 8 by 4. That is equal to minus b by a. That is minus coefficient of u upon coefficient of u square. Then product of zeros will be 0 into minus 2. So that will be 0, which is equal to 0 by 4, which is equal to constant term. As constant term is not there only, I will write 0 only and coefficient of u square. So I proved the relation also. Now let us take one more example where zeros are given to me. Find a quadratic equation with zeros root 2 and 1 upon 3 as now next question is find a quadratic equation with root 2 and 1 upon 3 as sum and product of its zeros respectively. So see here sum of zeros, that is alpha plus beta equal to root 2. and product of zeros that is alpha beta that is equal to 1 by 3. So therefore equation is I can say quadratic equation is x square minus alpha plus beta x plus alpha beta. So here if I put the values, so equation will be x square minus alpha plus beta is root 2 x plus 1 upon 3. So in denominator I don't keep 3. So I can make it multiply everything with 3. So 3x square minus 3 root 2x plus 1. So this is my required quadratic equation. Now next is exercise 2.2 question 1 that says find the zeros of the following quadratic polynomial and verify the relationship between the zeros of the coefficient. So first one is given x square minus 2x minus 8. So if I find the zeros of this polynomial, so I can say minus 8 such factor whose sum is coming minus 2. So I can write x square minus 4x plus 2x minus 8. So this will be x into x minus 4 and from the next two common, so x minus 4. Now both the brackets are coming common, x minus 4, so x plus 2. So either the 0 x minus 4 will be equal to 0 or x plus 2 equal to 0. So either x equal to 4 is my solution or x equal to minus 2 is my 0. So now sum of zeros, that is alpha plus beta, will be equal to 4 plus minus 2. So that is 2. And product of zeros equal to alpha beta, that is 4 into minus 2, that is minus 8. Now I need to verify it. So see how I will be doing the verification. Sum equal to alpha plus beta, which is equal to 2, which is equal to minus coefficient of x upon coefficient of x square. So if you see carefully, minus of minus 2 upon 1, so that is 2 upon 1, that is 2. And product alpha beta, which is equal to minus 8, which is equal to c upon a, so which is equal to constant upon coefficient of x square. So the first one is done. Now let us move to the second one. Second one says 4x square minus 4x plus 1. So here also 4 ones are 4. 4 such factor whose sum is coming 4. So 4x square minus 2x plus 1. So that will be 2x common. So 2x minus 1 and minus 1 common. So 2x minus 1. So this is 2x minus 1 into 2x minus 1. So either 2x minus 1 equal to 0 or this 2x minus 1 equal to 0. So x will be 1 by 2. Here also x is 1 by 2. So both are equal solutions. So sum will be alpha plus beta, that is equal to half plus half, that is 1, which is equal to minus 4 by 4, which is equal to minus coefficient of x upon coefficient of x square. Then product will be alpha beta, that is half into half, so that will be 1 by 4, that is equal to constant upon coefficient of x square. Then third one, it says 6x square minus 3 minus 7x. So this first I need to rearrange 6x square minus 7x minus 3. Now 6 threes are 18. 18 such factor whose sum is coming minus 7. So I can say 9 and 2. So 6x square minus 9x plus 2x minus 3. So from the first two I am taking 3x common. So 2x minus 3, and from the second I am taking 1 common, so 2x minus 3. So this becomes 2x minus 3 into 3x plus 1. So either 2x minus 3 equal to 0 or 3x plus 1 equal to 0. So either 2x equal to 3, so that is x equal to 3 by 2, or x equal to minus 1 by 3. So these two are the zeros, so sum of zeros will be alpha plus beta, that is 3 by 2 plus minus 1 by 3. So if I do LCM 6, so 3 twos are 6, so 3 threes are 9, plus into minus, minus 2 threes are 6, so 2 ones are 2, so 7 by 6. So now sum is 7 by 6, which is equal to minus coefficient of x upon coefficient of x square. Same way, product will be alpha beta, that is 3 by 2 into minus 1 by 3. So 3 cancel, so minus 1 by 2. That is C by A. So C is minus 3 upon 6, which is equal to minus 1 by 2, which is equal to C by A, which is equal to constant term upon coefficient of x square. Then fourth one, 4u square plus 8u. So here constant term is not there, so I can take 4u common, so u plus 2. So this can say 4u equal to 0 or u plus 2 equal to 0. So either u equal to minus 2 or u equal to 0 by 4, that is 0. So two solutions I got. So sum of zeros will be 0 plus minus 2. So that is minus 2, which is equal to negative coefficient of x upon coefficient of x square. So if you see carefully here, it is minus 8 upon 4, that is 2, minus 2. And product 0 into minus 2 will be 0, which is equal to constant term. Constant term is not there, so I can write in place of constant term 0 also. So constant term upon coefficient of x square. Then fifth one says t square minus 15. So this I can directly write t whole square minus root 15 whole square. So this will be t minus root 15 and t plus root 15. So one 0 will be t equal to root 15 and other 0 will be t equal to minus root 15. So sum will be alpha plus beta, that is root 15 plus minus root 15. So that will be 0. So equal to coefficient of t. See here, coefficient of t term is not there upon coefficient of t square. So I can write 0t. So I got my answer. And product will be alpha beta, which is equal to root 15 into minus root 15. So that will be minus 15. So which is equal to C by A, which is equal to coefficient constant upon coefficient of t square. Here it is t. Now coming to question 2, it says find a quadratic polynomial each with the given numbers as the sum and the product of its zeros respectively. So first one is 1 by 4 comma minus 1. So see, sum is 1 by 4, product is minus 1. So I can say equation will be x square minus alpha plus beta x plus alpha beta. So this will be x square minus alpha plus beta is 1 upon 4x plus minus 1. So this will be, if I multiply everything with 4, so 4x square minus x minus 1. Then second one is root 2 comma 1 by 3. So here, if you see carefully, sum is root 2 and product is 1 by 3. So equation will be x square minus alpha plus beta, that is sum, plus product, that is alpha beta. So x square minus root 2x plus 1 by 3. So this equation I can write 3x square minus 3 root 2x plus 1. Then third one is 0 and root 5. So sum is 0, product is root 5. So therefore equation will be x square minus sum, the 0x plus root 5 product. So that will be equal to x square plus root 5. Then fourth one, 1 comma 1. So sum equal to 1, product equal to 1. So equation will be x square minus sum. So 1x plus product 1. So this is x square minus x plus 1. Then fifth one, minus 1 by 4, 1 by 4. So sum is minus 1 by 4, product is 1 by 4. So equation will be x square minus sum. So minus 1 by 4 x plus 1 by 4. So if I multiply with 4 everything, so 4x square minus into minus plus x plus 1. Then sixth one says 4 comma 1. So sum is 4, product is 1. So x square minus 4x plus 1. This will be my required equations.